welcome back, and I'm so glad with the learnings that you are taking. So, the modern periodic table that you see, this that we study today, was given to us by Henry Moseley. In 1913, he gave us the modern periodic law. So, by this time, we were having a full fledged atomic structure. Henry Moseley's story is like very inspiring and a little sad. So let us look at Henry Moseley's profile. So Henry Moseley was an English physicist, okay? And he has given us the concept of empirical formula, and then he's also given us the most important atomic number. Now a little story about Henry Moseley. Somewhere around 1914, okay, in the first half of 1914, he resigned from his position at Manchester, okay, and he wanted to return to Oxford for advanced research, and he wanted to continue his research there. Now, what happened is around that time, in August 1914, the World War I broke. And instead of going and resuming his work, he wanted to serve the nation. So he wanted to be with his country at this testing time. So he enlisted with the Royal Engineers of the British Army. Of course, his family and friends said, you have a bright future and you are required, to be with us, and you should go back to your studies. But he refused to do that. He instead wanted to serve his country, and he served as a technical officer. And he was given the duty of deciphering the telecommunication. Okay. And around, this is like really very emotional. So every time I say this, I feel really bad. He was so young. He was not even 30. Okay. So in April 1915, while he was acting, he was communicating the telephonic message, he was shot by a sniper. Okay. And he was killed on the spot. So in 1914, okay, when Moseley left, his age was not even 30, okay, and he has already done so much in the field of science. So scientists say if he would have been alive for a longer time, this world would have been a real advanced world, fast inventions, and we would have had so many aspects of sciences known to us, okay, if he would have been alive. So I must be talking about this story like about the 20th or maybe the 50th time, but every time I say this, I get very emotional. Yeah, so that was about Henry Moseley. Now let us talk about the modern periodic law. So Moseley's periodic law or modern periodic law is just in the language of Mendeleev. Remember Mendeleev's periodic law? I want to look at that first, then we'll again read it. Mendeleev's periodic law says properties of elements depend on the atomic weight. That is, if you arrange elements in increasing order of atomic weight, properties repeat periodically. So once again, the properties of elements are periodic function of their atomic weight, whereas modern periodic law says that properties of elements are periodic function of the atomic number. So I'm going to show it to you one more time, dear students. Mendeleev's law says that properties of the elements are periodic functions of their atomic weight, whereas the modern periodic law says that the properties of elements are periodic function of their atomic number. And this was so much logical now because we know that atomic number represents the number of protons. Number of protons equal to the number of electrons. Electrons give us the electronic configuration, and electronic configuration tells us the valence electrons. Valence electrons talk about the valency. Valency talk about the chemical behavior, which is the chemical property. So of course the properties are dependent on the atomic number. Okay, so the modern periodic law, which holds true for all the elements, that is, properties of elements are periodic function of the atomic number. Okay, students, if you got this, great. Otherwise, please go back and watch this segment of this modern periodic law one more time so you'll understand the relationship between atomic number up till valency. Good job. So in simple words, when elements are arranged in increasing order of atomic number, the elements with similar properties repeat after regular intervals. That is, the properties repeat, not the same element. Like lithium has some property, after some time sodium will have similar property. Potassium, a higher element, will have a similar property. Okay, so that is called as a modern periodic law. Now let us look at the modern periodic table. I already showed you the picture of the modern periodic table. So if you look at the modern periodic table has got 7 horizontal rows. First row has only 2 elements, hydrogen and helium. Second row has got this 8 elements. Third row also has 8 elements. If you look at the fourth row, this is the fourth row. It has got 18 elements from potassium to krypton, if you actually count the 18 elements. And can you see on the top, there are numbers given? So on this number is not visible, but this is group number 1. Group 1, group 2, group 3. So these vertical columns are called as groups. Okay, these are groups. So we have total of 18 groups. So this is group 1 and this is group 18. Okay, so let me see if I can just add it here. Okay, the groups maybe, yes. 1 and this is going to be group 18. So let me just and take it here and make it as 18. Okay, so group 1 and group 18. So let me see if I can put it here, group 18, group 1. So how many groups are there total? There are total 18 groups and there are 7 horizontal rows. Now you'll say, ma'am, but what about these two things at the bottom? So these two series at the bottoms are not separate rows, but can you see this green line? These all 14 elements are supposed to be sitting here between lanthanum and hafnium. Okay, so these all 14 elements from cerium to lutetium are supposed to be here, and these 14 elements in red are supposed to be here after actinium. But if you would put these 14 elements here, this periodic table would have been like stretched out and would have been looked very, unsymmetrical, inconvenient for us to put it on a paper. Therefore, we decided to put these 14 elements at the bottom, right? This 14 from lanthanum to hafnium, and also the ones with the red, which is the first series is called as lanthanide, the second series is called as actinides. Wasn't it smart? Yeah? Yes. So these elements were kept separately, but they belong to the same period. So the entire periodic table is such. We have 7 horizontal rows called as periods, 18 vertical columns called as groups. Okay, let us look a little more about this in this segment. So, the modern periodic table is called as a periodic table because I said that the properties repeat periodically. Okay, the structure of the periodic table shows trends. I told you in the whole table there is going to be trend in the atomic behavior, that is the atomic size will change. There is something called as ionization potential that is going to change. This is going to increase or decrease. So there is a trend. Okay, then it is seen that there are 7 horizontal rows called as periods, and on the left side of the period is usually a metal, on the right side is a non-metal. The last period actually is of no connect, it's a noble element period. There is no reactivity of that. Also, there are 18 vertical columns called as groups, and there are some important groups that we are going to study in this series. Okay, we are going to look at group 1, which is called as the group of alkali metals, group 2 alkaline earth metals, group 17 that is called as the elements are called as halogens. Okay, so we are going to look at even the group 18. So group 1, group 2, group 17 and group 18 we are going to get into a little bit of detail. We'll try to understand or at least we'll remember all the elements from that group and slightly understand the chemical behavior of that element. Of that group. And and the best way is, if you know the chemical behavior of any element of this group, you can understand the chemical behavior of all the other elements of that group. Now the behavior is not same, but it is similar. Okay, so that's about the modern periodic table. We saw the structure of the modern periodic table. We saw why it is called as a periodic table, and we also learnt about the life and the life purpose of the person who gave us the modern periodic table. So that's all for this video. In the next video, we are going to look at the first 20 elements, the atomic number of the first 20 elements, and we'll also remember the name, okay, in the order of 1 to 20. So that's all for this video. I'm going to see you in the next video, but you are going to comment after this video. If there's anything interesting that you want to share, anything that you know I have not mentioned in this video, you want your community to know about Henry Moseley or maybe Mendeleev, or you have studied and researched about the Birinier Newland, let us know. And some interesting facts or something that shows you are a dedicated, committed student, you can get a reward from us. Okay, so take care. I'll see you in the next video. Bye.